Well, good afternoon, everyone, and welcome to today's live astronomy show. My name is Justin. I'm one of the astronomers here at the Science Museum of Virginia, and I'm happy to be with you again today. If you've watched some of the previous episodes, welcome back. If this is your first time tuning in, glad to have you on board. I've been doing these since early in the summer, so we've got some old episodes archived. If you want to catch up, you don't have to have watched old episodes to enjoy today's show. You can find them right here on Facebook in our video archive. They're posted on YouTube as well. And as always, need to thank our sponsor for this series, Allianz Partners. Happy to have them on board as well. A couple of things before we get started, just in case you are watching for the first time. This is going to be a live trip through the universe. So today we are staying in the solar system. We're going to be using similar software to what we use here in the dome at the Science Museum. It's planetarium software called Digistar 7. And it can do some pretty cool stuff. So if you're able to watch this full screen, I recommend it. If you've got a nice big monitor, you should see some pretty cool stuff going on too. In fact, let's get switched over to the Digistar view, show you what we're going to be talking about today. And I'm going to start by kind of flashing back to something that happened over the weekend. Now, if you're watching NASA TV on Saturday, you know that they conducted what's called the Green Run of the first stage of the SLS rocket. I believe in the last show, or the show before, I talked about how this rocket is going to be used in the Artemis program, and hopefully Artemis 1 launches later on this year. This was the first time that all four engines on this rocket stage had been tested together. It's useful to do these kinds of tests before you send a rocket like this into space for the first time. Now, the plan was to fire all four engines for a little over 8 minutes, the amount of time it would take to get the SLS rocket into space. Before the test, NASA had said that at the very least, they hoped to fire the engines for about 2.5 minutes. That would give them enough data to confirm they had passed the test. Now, I wouldn't show you the entire test if it had gone the full duration, at 8 minutes or so, but I am going to show you the whole test because the engines shut down a little bit early. It was a little after 1 minute into the test. Still a pretty spectacular event. Turns out that they had set some limits on their hydraulic systems, the things they use to actually move the engine bells to steer the rocket as it goes into space. They'd set some tolerances on those a little bit lower than they would be for actual flight, and they exceeded their limits. The rocket engines shut themselves down as they should have, so I guess that was a good thing. But NASA is still trying to determine whether the test was successful enough to move forward with launch preparations. So already making some progress on the Will It Happen segment I did earlier in the year. A little bit of uncertainty around the SLS rocket now. Let's see, another thing we can flash back to is the Juno mission. I brought that up in the last episode 2 weeks ago. Juno is a spacecraft in orbit around Jupiter, and talked about it a fortnight ago because of its very low perijose, its close approaches to the planet Jupiter, and mentioned that its mission got extended. So Juno is now going to be operating here in orbit around Jupiter until September of 2025, or until the spacecraft shuts down, whichever comes first. Now, the most exciting part about this is it's going to allow the spacecraft to make some close approaches to some of the moons of Jupiter. The orbits of 4 of the moons on the screen for you, and I'm building up the orbits the Juno spacecraft has followed over the course of its mission. I can show you the whole future of the Juno mission out into 2025 now, and we'll see how close it gets to the orbits of some of those moons. And I just kind of wanted to show you this picture because I think it looks cool. But it's also a way to introduce the main topic for today's show. Wanted to get into some of the earliest missions to explore Jupiter and its moons, because today is, well, an interesting anniversary. On this day, back in 2003, the first spacecraft to fly by Jupiter, Pioneer 10, sent its last transmission to Earth. So that spacecraft fell silent. But it was after operating in space for a little over 30 years, so it was pretty successful, and saw some pretty cool stuff along the way. So I thought I would flash back all the way to the early 1970s. We take a look at the first missions to blaze the trails to the outer solar system. Juno wouldn't be out there today if it weren't for spacecraft like Pioneer 10. The one I'm paying tribute to in the background over here, Cassini, that one probably wouldn't have been launched towards Saturn if it hadn't been for some of these other missions. So let's take a look. Now, it's important to put these missions in a little bit of context. We know a lot about the solar system today. We're used to seeing some really amazing pictures of worlds all throughout the solar system today. But the world was a little bit simpler place in 1972, where we were going to start our journey. And our map of the solar system was a little simpler back then too. We had the Earth there, certainly. We knew that existed. We had the planets. We knew all of those were out there. In fact, we still counted Pluto as one of the planets in the solar system. Those ideas have certainly evolved a little bit. And then some of my favorite objects, asteroids, well, they knew of fewer than 2,000 of them. So there's every single asteroid that we knew existed in 1972, and full of comets mixed in there as well. So this was the solar system in the 1970s. Now we're talking about exploring the solar system, so let's take a quick glance at that as well. So I'm going to dive back into the inner solar system, and I'm going to use some graphics that might be familiar to those of you that have watched previous episodes. I like drawing big circles around things, and each circle represents a different spacecraft we've sent to explore another world in the solar system. So kind of ignoring the satellites that are in orbit around the Earth. Plenty of those back then and today. But let's see, the moon. We certainly had sent some spacecraft to explore the moon. By 1972 rather, most of the Apollo missions were actually completed as well. So there had been 11, 12, 14, 15, 4 different missions that landed on the moon. We're going to talk a little more about those in the next show. And I've got a couple of big blue circles drawn around the sun here because some spacecraft have been sent into orbit around the sun to study our nearest star by now. Just a handful of them. Then in terms of other planets, well, we had sent some spacecraft to Mars. Certainly, we're going to talk more about current missions to Mars in a couple of weeks, but there's Mars. Now, as with what we saw at the moon and some of the previous episodes here, when I draw these graphics, they're color-coded based on which country launched their missions. And if you see that one of the circles around, in this case Mars, is either dashed or kind of disappears, if we drift away from it a little bit, that means that mission wasn't very successful. So we'd sent, about a dozen spacecraft towards Mars, but about half of them had failed. A similar story if we dive in towards Venus here. About a dozen different spacecraft have been sent in this direction, but there was a big gap in that little map of exploration. A lot of those spacecraft had failed. So we're starting to reach out and explore some of the other planets in the solar system, but things didn't always go as planned, and some of those missions had failed. That didn't stop NASA from deciding it was time to head to the outer solar system and launch Pioneer 10. So we're going to pick up with Pioneer 10's journey to Jupiter. Now, it's not an easy journey. This was the first time that NASA had sent a spacecraft into the outer solar system. So Pioneer 10 set some interesting records along the way. After it crossed the orbit of Mars, it became our most distant spacecraft we'd actually communicated with. Some other spacecraft had flown by Mars and we lost contact with them. They were those failed missions I showed you before, but Pioneer 10 still going strong. It enters the asteroid belt. Pioneer 10 was the first spacecraft to fly through the asteroid belt. Of course, in those days when we only knew of a couple thousand asteroids, we were pretty certain it wasn't going to run into anything. In fact, NASA estimated that Pioneer 10 wouldn't get any closer than about 4 million miles to any of the asteroids known to exist at the time. But they thought those asteroids suffered a lot of collisions. There might be a lot of tiny particles, that secret word was a month ago, that might have been colliding with each other and might disable the spacecraft. But Pioneer 10 got through the asteroid belt safely. Since we have now discovered over 1 million asteroids, I can say with some certainty that Pioneer 10 probably got closer to an asteroid than they realized at the time, but with such a long list, it's tough to work backwards and find which one it may have gotten closest to. And then after safely exiting the asteroid belt, it was on to the main event for Pioneer 10, Jupiter. Now, our picture of the Jupiter system was even a little bit simpler in those days. We now know that there are 79 moons, at least, in orbit around Jupiter, but only counted about a dozen in the 70s. And the hope was that Pioneer 10 would be able to fly by, maybe observe a couple of those moons, observe the planet, and let's see what it actually saw. I want to get just a little bit closer to Jupiter before we slow things down here. That ought to do it. Let's stop right about there, and let's zoom in and take a closer look. Let's follow along in the footsteps of Pioneer 10, see what it saw. Already by this point, the images that it was collecting were better than any that we could collect with telescopes here on the Earth. But as you're going to see, the cameras on the Pioneer spacecraft weren't all that great. So we got some pictures of Jupiter. They were not crystal clear. In fact, the map that I've got on Jupiter is actually based on the real images that Pioneer collected. So let's accelerate our clock here just a little bit, get just a little bit closer to the planet so you can see what things actually look like. And I'll put some real pictures on the screen for you too. It should be close enough to start to see that some details are starting to jump out. You got some of the stripes in Jupiter's atmosphere that we're all used to, the great red spot. That'll come back into view one more time here before we make our closest approach. We can see now that this was a storm in the clouds, but not all that much detail on the planets. There we go. That's about as good as we're going to be able to see with Pioneer 10. Pretty interesting, but a lot of details left out. Here comes some real images from the spacecraft. Let's see if we can get those up there for you. So better than any others that we had at the time, but we're used to seeing Jupiter in a lot more detail today. And then there are the moons. Here come pictures of, what is that, Ganymede? Hard to tell. And then Europa is the other one. So kind of whetting our palate in those days for what other spacecraft might see in the future. As for Pioneer 10, it had successfully traversed the asteroid belt. It had successfully flown by Jupiter, and well, it was on its way out of the solar system after that. It flew by the orbits of the other planets, but the planets weren't there, so it didn't see anything. After it crossed the orbit of Neptune, it entered a region that we now know as the Kuiper belt. We know of thousands of objects out here, but in the 70s they had no idea. It traveled safely through the Kuiper belt without running into anything else. But in 1992, something kind of interesting happened. Here on Earth, astronomers started discovering Kuiper belt objects, but astronomers also noticed that Pioneer 10 deviated from its expected course just a little bit. Now, the only way to do that, since the spacecraft hadn't fired its thrusters, would have been to maybe fly by some unseen object out here in the outer solar system. Did Pioneer 10 fly close to a Kuiper belt object? Well, we haven't found anything in the decades since that could explain it, so maybe. I guess maybe the fuel tanks on the spacecraft sprung a leak or something too. Maybe there are other explanations, but I think that's kind of the coolest possibility for Pioneer 10 after flying by Jupiter. Maybe it had a close shave with something else in the Kuiper belt. And this transmitter's fall silent after it runs out of power. We'll revisit that at the very end of the show. But first, of course, Pioneer 10 had a follow-up mission. A few more spacecraft visited visit the outer planets a few decades ago. Pioneer 10 followed up by Pioneer 11. This is that spacecraft, a virtual twin of Pioneer 10, launched about a year later and flew by Jupiter about a year later as well, in early 1974. Now, Pioneer 11's trajectory was a little bit different. You might already tell it's a a little bit different on your screen here. I'm going to try and keep some part of Jupiter on the screen for you, but it's going to be a little bit of a struggle. Hey, that's actually pretty good because Pioneer 11 got much closer to the planet than Pioneer 10 did. That allowed it to get some pretty unique images. We got our best view of the Great Red Spot to that date, and also gave us kind of our first hint of Jupiter's polar regions. Juno has actually filled in those gaps pretty well. Then Pioneer 11 did something kind of neat. This close approach by Jupiter altered the spacecraft's trajectory. We do this all the time now. It's a gravity assist, and the one that Pioneer 11 received was pretty extreme. It actually lifted the spacecraft up above the plane of the planet, so kind of flew over the asteroid belt to get to the other side of the solar system. And by the time it got there in 1979, Saturn was waiting for it. So this pretty extreme gravity assist allowed Pioneer 11 to be the first spacecraft to visit Saturn. And well, bound to see something interesting if we take a closer look. So let's dive in with Pioneer 11 here and take a closer look at Saturn. Now, the spacecraft, again, we're dealing with these cameras that don't give these crystal clear images. So Cassini would give us our best images of Saturn that we've gathered to date, and some other follow-on missions would give us good views as well. Kind of the coolest moment here at Saturn, I think, is as Pioneer 11 was approaching, it got pretty close to a moon that nobody knew existed until the day before. It came within about 4,000 miles of the moon Epimetheus. I can just imagine if they had been a slightly different course, maybe they fly over 1 billion miles, actually run into that moon. It would have been pretty tragic for the mission. But luckily they spotted it. They were not on a collision course, and the spacecraft was able to take some pretty unique images. We get the best views of Saturn that we had up till that time. Got some tantalizing views of the largest moon, Titan, that would kind of help us elevate it in the list of priorities for future missions. And then Pioneer 11 travels on, doesn't see any other planets. But with these successful flybys of Jupiter and Saturn, these successful gravity assists, safely traveling through the asteroid belt, determining that the radiation environment at Jupiter wasn't too dangerous, it helped engineers back on Earth plan and design future missions, like the Voyager spacecraft. Scientists knew that in the late 1970s, the gas giants in the outer solar system would be nicely aligned so that with these gravity assists, you could use spacecraft, you could use the planets to kind of jump spacecraft from planet to planet. And so this idea of a grand tour of the planets was born. And the Voyager missions were the grand tour that we got. So Voyager 1 and 2, they launched a few weeks apart, and then they flew by Jupiter a few months apart. I just synced them up here for the sake of time during today's show. It gave us some pretty amazing views of Jupiter and its moons. Yes, we've revisited Jupiter since. The Galileo spacecraft was in orbit around Jupiter for about 7 years. Juno is there now. But I don't know, there's just something about some of the Voyager images, some of them I think have not really been bested in the decades since. So here you're seeing some of the real images from Voyagers 1 and 2. Jupiter, its great red spot, this giant storm, its moons. The Voyager spacecraft discovered a few new moons, made amazing discoveries, like Voyager 1 saw active volcanoes on Io for the first time. This was the first time we knew that there were active volcanoes on some other world in the solar system. Saw a cracked surface on the icy moon Europa, suggesting that its icy surface was covering a liquid water ocean. Similar story with the largest moon in the solar system, Ganymede. Barely recognizable in the images from Pioneer 10, but now we see amazing detail. And with Callisto, saw a surface saturated with craters, one of the oldest surfaces in the solar system. Pretty amazing. The list goes on. And then there are the rings. Yeah, Jupiter has rings as well. So add that to the list along with Saturn for ringed planets in the solar system. Pretty cool. Now, this were all the Voyager spacecraft had accomplished, I think it would have been worth it. But they continued on. And let's see, before we move on, I've removed some of my images from the screen. Got a message. Let's see. Chase asks, did the moon change their trajectory at all? I'm guessing that Chase, that may refer back to, I'm sorry, I didn't see exactly when your question came in, guessing that that was referring back to Pioneer 11 and flying by Epimetheus. Epimetheus is pretty tiny. Its gravity isn't strong enough to really change the spacecraft's trajectory much. The way that they detected it, so they saw it in pictures the day before, but then when the spacecraft flew by, they kind of noticed that it moved through the spacecraft's, that it moved through the moon's shadow. So they noticed that kind of the magnetic fields it was detecting changed. So it's kind of a change in the solar wind that they were flying through. So in the case of Pioneer 10, Epimetheus, the moon's not really changing the path too much. Some of these bigger moons, like the Voyager spacecraft, flew by to Jupiter, and as we flash forward to Saturn, yeah, these big moons can change spacecraft trajectories quite a bit. So let's keep following along with the Voyagers. So yeah, they fly by Jupiter. They use Jupiter's gravity to alter their courses, and they are able to fly by Saturn as well. Again, they flew by at different times. Just in the interest of time for today's show, I'm going to sync them up for you here. The spacecraft trails are color-coded. The positions of the moons when the spacecraft visited are color-coded for you too. The first thing to watch here is that Voyager 1, in blue, it visited a moon up close. That was Titan. After Pioneer 11 showed that it did have a thick atmosphere, the scientists working on Voyager want to make sure they got a good view. So make sure that Voyager 1 flew by Titan. Then after it did, flew by Saturn, got some great images. Then the gravity of Saturn alters the course of the spacecraft. And as we rotate around here, look at how different the spacecraft trajectories are after visiting Saturn. They were on very different trajectories after that. But of course, they saw some pretty cool stuff in the Saturn system. You've got the planet itself, the vibrant atmosphere, active storms in the atmosphere of Saturn here as well. You've got the rings of Saturn. The Voyager spacecraft revealed dynamic changes in the rings of this planet that were a little bit unexpected. The moons, well, Titan was a top target, and Voyager 1 confirmed that its visible light cameras could not see through the atmosphere of the planet, and imaged a lot of the other icy moons here as well. Hints of amazing discoveries yet to come if we ever returned to the Saturn system to stay. Now, if this were all that the Voyager spacecraft had accomplished, probably would have been good enough. Still would have been worth it. But because of the little nudge that Voyager 2 got from Saturn, it was able to continue on. It flew by 2 more planets, completed kind of the grand tour of the gas giants in the solar system. In 1986, Voyager 2 would fly by the planet Uranus. In 1989, it flew by the planet Neptune. Made amazing observations and discoveries at both of these planets as well. At Uranus, the atmosphere of the planet looked kind of featureless, but more modern image processing has revealed some incredible details. We got new observations of the rings of Uranus. Yeah, it's got rings too. As for the moons, it observed several that were already known. And then Voyager 2 discovered 10 new moons in orbit around Uranus. At the time, that tripled the number of moons that we knew existed there. That's pretty amazing. Then at Neptune, saw a dynamic atmosphere. A giant storm was raging at the time the spacecraft flew by. That so-called Great Dark Spot has gone away, but there's a new one there today. It studied the rings of Neptune. That planet has rings too. all the gas giants have rings. They studied some of Neptune's moons, discovered a couple of new ones, and the images that it collected of Triton, Neptune's largest moon, were so intriguing that there's a brand new mission in an early planning stage that is a finalist for funding from NASA. So the hints of geologic activity and possible volcanism that we saw on Triton were intriguing enough that we want to build a new spacecraft to fly all the way across the solar system again, just to see Triton up close one more time. So, if this were the only thing the Voyager spacecraft had accomplished, well, I think that would have been worth it. But they weren't quite done yet. A few more interesting wrinkles to the journeys of the Voyager spacecraft. Voyager 1, although it wasn't able to see any other planets after passing Saturn, on Valentine's Day, 1990. Before turning off its cameras for the last time, it collected one more set of images. It turned its cameras back towards the solar system. It took pictures of where it had come from. It scanned across the planets in the solar system and captured what is called the family portrait of the solar system. Now, Mercury and Mars, a little bit too dim and too close to the sun to be seen. Pluto, still counted as a planet, but didn't show up in the images either. Still, Earth, Venus, Jupiter, Saturn, Uranus, Neptune, all seen in this family portrait. They don't look like much. The spacecraft was some 4 billion miles away, so there's little tiny dots, but it did give us this amazing image of the Earth. The Earth from 4 billion miles away, one little tiny pale blue dot there, given that nickname and immortalized under that name by Carl Sagan in his book of the same name. That's your weekend reading assignment. Check out the pale blue dot. Now, if that image were the only thing the Voyager spacecraft had sent back to us, it's a little bit of a stretch, but it might still have been worth it. But they weren't done yet. The instruments on these spacecraft were able to study more than just planets. They had more than just cameras on board. They were able to study, as I've kind of alluded to, magnetic fields, plasmas, charged particles streaming through the solar system. The solar wind streams away from the sun all the time. We've got previous episodes that talk about stars and the sun to give you a little more detail on that. And so these spacecraft were able to continue to make measurements of the plasma environment, the sun's kind of extended atmosphere out here in the outer solar system. So there you see the current positions of the Voyager spacecraft, the Pioneer spacecraft, added New Horizons to the map as well. That's a more recent spacecraft, famous for flying by Pluto and another Kuiper belt object. But these spacecraft, still able to make interesting discoveries. Pioneer 10 fell silent on this day in 2003. As mentioned, Pioneer 11 had actually already shut down by that time. But New Horizons and the Voyagers still operate. In the case of Voyager 1 and Voyager 2, it's after more than 40 years in space. Now, just like they were able to fly through the solar system safely, get through the asteroid belt and the Kuiper belt without running into anything, as they exit the planetary realm of the solar system here and eventually leave the solar system altogether, they'll journey through the galaxy, but they shouldn't run into anything else. The galaxy also mostly empty space, even though it contains hundreds of billions of stars. Still, on the off chance that somebody does discover these space probes as they wander through the Milky Way, we've included some messages on board. The two Voyager spacecraft have the famous golden records. Comes with instructions on how to use it if you really want to. It's got a little map there that can help you find where the solar system is. You can find where these probes originated. The Pioneer spacecraft have some similar imagery on a plaque that is affixed to the spacecraft. No music for aliens might find the Pioneer spacecraft to enjoy, but maybe they can trace the origins of the spacecraft back to the Earth. So even after all of these spacecraft shut down, whether they're found by other civilizations or not, I think the fact that we're able to put these messages together and think of how we might want to describe ourselves to other civilizations is a pretty powerful thing too. Speaking of power, as one parting message, I should mention how these spacecraft were able to operate over such long distances and over such long times. I mean, the The Voyager spacecraft, still operational after more than 40 years. What could power these spacecraft over such great distances in space and time? Yeah. All of these interstellar spacecraft relying on the power of the atom. Plutonium atoms, to be precise, created billions of years ago in neutron star collisions. We've mined them from the Earth here, included them in our spacecraft. As that plutonium decays, it generates heat. The heat is transformed into electricity that is used to power the instruments. What happened to Pioneer 10 in 2003? Well, enough of the plutonium had decayed, and the rest of its electronics had decayed to the point that it just couldn't power its instruments anymore. The same happened to Pioneer 11 prior to that. The same will happen to the Voyager 1, 2, and New Horizons spacecraft, but those last three should operate for maybe 5 to 10 years more. So we've got a lot more to see from these spacecraft in the outer solar system, but for now, I should wrap up the show. Looks like we got one more question before I end the show today. Terry asks, do any of the spacecraft I've talked about still transmit images? Well, Voyager 1 and 2, they're far enough away, there's not a whole lot for them to see. So no, their cameras have been powered off, and they're using, or they've got enough electricity available, low enough amount of electricity, I should say. They can't power all of their instruments. So since there isn't really anything to see, they've turned off the cameras, but those instruments that can detect the solar wind and magnetic fields, they are still operating. New Horizons is still collecting images. It flew by Pluto in 2015. It flew by another small Kuiper Belt object named Arrokoth on New Year's Day 2019, and they're still observing other Kuiper Belt objects from a distance. They can still learn unique things, and there's still some hope they'll find another object to fly by at close distance. So those cameras are still operational. See another question from Chase. What is your favorite spacecraft that we have ever sent into space? Asking as humans, not just the United States. Oh man, Chase, that is a good question. It's hard to pick favorites. Although I guess I'm a little partial to some of them I've actually seen launch from the Earth, and a couple of those are OSIRIS-REx and TESS. They feature pretty prominently on some of the previous episodes, and I dare say we haven't seen the last of them in these online shows either. So OSIRIS-REx, TESS, studying asteroids and exoplanets. So those are probably near the top of my list. Thanks for the questions so much, guys. If you've got more, feel free to keep adding them in the comments. Might inspire some future episodes, or we can return to them and just answer them in the comments for you later on today. Would be happy to return to some of your favorite topics in future episodes as well. So if you have ideas for future shows, feel free to leave those in the comments as well. Maybe you can inspire a whole episode, just like Pioneer 10 Falling Silent inspired this whole episode. Since we're trying to post these events before they actually happen, feel free to share future live streams as you see them as well. You can set a reminder that we're about to go live, and just as a reminder, we are doing these roughly every 2 weeks. We'll be back in 2 weeks with you on February 5th, I believe it is, and then a slight adjustment. Originally scheduled show would have landed on February 19th, but on February 18th, some pretty cool stuff is scheduled to happen at Mars, so I'm going to bump up the show by a day, and hope to see you then. For now, though, I should let you get on with the rest of your Friday afternoon, or whenever you're watching this in the future. Thanks for joining me today. I hope you enjoyed the show, and I hope to see you again in a fortnight. Until then, stay safe out there.